Neuroplasticity is a beautiful concept. Now, here people say that a child only develops during the initial years of his age. And once the brain develops till the age of 5, after that, our brains remains the same. So it is the skills and abilities or whatever we learn. It is only during the initial years that we learn well. And later on, our brain more or less, it stays the same. But that is not the case. Neuroplasticity has completely changed the way we look at the world, the way we look at the human brain. So neuroplasticity exactly is what? It is the ability of the brain to keep changing throughout the course of life. So these changes occur in the brain by what? By making and breaking of the synaptic connections between the neurons. So our whole brain is full of neural connections. There are many neurons in the brain. Millions and billions of neurons are there. Since we were born till now, there have been, a lot of neurons, and they keep on breaking and making, and it depends on what we are doing in life, what decisions are we making. It's the genetic makeup, it is the structure of the brain, it is the environment. There are multiple factors that influence the making and breaking of synapses. So that keeps occurring throughout the life. Neuroplasticity, the neural network that is there in the brain, it completely changes the brain, and these changes can be due to genetic or due to environmental. So before we go into the technicalities of what are the terminologies in neuroplasticity, what you have to write in your answer when the exam comes, before going to that, let me explain neuroplasticity in a very, very layman language so that you understand the concept really well. So let's say this is your brain, and there are several neural connections in your brain. Throughout the brain, there are millions and billions of neural connections that are there, and there are synaptic connections of the neurons that are there. Now in this, what happens is there is a certain connections that have been made already. So let's say I have certain kind of connections in my brain, and I all of a sudden I feel like, okay, let me just learn dance. It's a new skill. I've always wanted to learn dance, but I never got a chance to do it. So let me do it now. And I join this class and I start learning. So initially I'm performing very poorly, and gradually over a period of time, maybe like say 10 months or so, I start to perform better. I'm mastering the skill, and my abilities are improving in dance. So what is happening? Whatever the functions are needed for dancing, your motor skills, your balancing, your movements of the body, all these things, the muscles and everything. So all these things that are needed for the dance, those specific connections in the brain start to develop. So there are more synaptic connections that are getting made in my brain for these certain things. Or for example, let's say I had never driven in my life, and I always used to take a cab, or my family used to drive for me or something like that. And all of a sudden I think now I need to work on my driving skills. I'll start learning how to drive. So when I start learning to drive, when I'm driving, I am using so many sensations. I'm using so many stimuli which I was never using before this. So for example, I am able to map the city. I'm able to understand the maps of the city. I'm able to know where this road is leading to, how to see that the car is coming from the right side or the left side, or any car is behind me, how to do the reverse, and all these things about the driving. So I get to understand all these things, and I start paying attention to all these things which I had never done before. So what happens? Whatever is needed, whatever skills are needed, whatever connections or areas in the brain that is being used, in those particular areas, the synaptic connections start to build up stronger. So more I drive, better I get, because more synapses are being connected. So those specific areas, the spatial ability, my motor movements, and my attention to all these things, those particular parts of the brain which are being used to do that ability, those parts of the brain start to get developed. So basically in neuroplasticity, what happens? If you are using your brain in a certain thing, those synapses are going to become stronger, and the brain parts which you are not using, those began to break. So it simply means that brain thinks, okay, you are using your certain parts of the brain for this thing, I am going to make more synaptic nerves for this very thing, and you become better at it. If you're not using your brain thinks, okay, maybe this part is not needed anymore, so there is no point in making more synaptic connections in the neurons for this particular thing, so that part begins to shed. I'll again another give you an example. Now, many times you would have come across, mothers yelling at kids or telling their kids, don't watch TV. Why don't you read a book? Reading a book is better than watching a TV. Why don't you go out to play? Why you keep sitting in a room? And things like that. So all the time we are yelling at our kids to do these things. Now, why do we tell them to switch off the TV? Why do we tell them to read a book? Or why do we tell them to go out and play? The simple reason is, when they are reading the book, they are increasing the language ability, is going to increase their vocabulary, the familiarity with the words, the spellings, and so on. So when they keep doing it, the particular part of their brain, the specific parts of their brain which are used in reading, your language, your comprehension, your understanding of things, your imagination while you're reading, all these things are being used. When these things are being used, there are more synaptic connections building up in your brain. And when you are not reading, when you are not playing out, when you're not doing such productive activities, what happens? Your brain thinks that these particular synaptic connections are not needed. This person doesn't need all that. So let it be. Let's just, shed these connections. Let's break these connections because they are not in use. I don't do maths at all. I don't do mental calculations. I don't calculate things in my mind, and I always use a calculator. Now, brain gets a signal that this person doesn't need those mental ability skills. So those connections are going to break, and I might, have lesser ability in doing mental maths altogether. But more the maths I do, those particular parts of the brain are going to build up more connections, neural connections. Hence, I will get better in that subject. So that is why when your mother is yelling at you that don't watch TV or don't get into your iPad and mobiles, go out to play, do some productive action, or do some productivity, or read a book, or maybe listen to a nice song, or do some creative art or something, follow your hobby. In that case, please do listen to her, because she is only trying to make or build the neural connections in your brain, and she doesn't want the neural connections to break in your brain. The time we are born till the time we die, these neural connections keep on changing. It all depends, how you use it. I will give you one more example. There are many people who, till the time they're doing their jobs, they are performing so well, they are so active, and they can do a lot many things which are very productive in nature. The moment they get retired, now what is happening? After retirement, they don't use their brain in the way they were using it before. For example, some people, not all I'm saying, some people, they think, okay, now I'm retired, now I don't want to do anything, I'll just sit and relax, so I'll not do anything at all. So what happens is, when they are not doing anything at all and they're just sitting and relaxing, basically the neural connections are breaking in their brain, and they tend to get older, like mentally older, faster. And the people who keep working as in not draining yourself out after the retirement, but keep using their brain, maybe like playing a Sudoku, or doing a gardening, or doing some trading or things like that, maybe reading a book even. So these kind of things, if you keep your brain active, then what happens? You don't get older faster. Why I'm saying older faster, not as in really the aging thing, but older faster as in your brain stays active for a longer period of time, and it stays active in a very good qualitative way. So this is important, that we tell people who get retired to keep doing something and not just sit and relax and give up everything, because you're going to age much faster. So this is what neuroplasticity is. So the first terminology that you need to remember and must write in your answer is synaptic plasticity. What is synaptic plasticity? It is the connections making or breaking at a very simple level. So basically it is the ability of a neuron to make the connection or synaptic connection or break it. So it is at a very simple level on the neuron level. Second important terminology is cortical mapping. Cortical mapping is a larger part. It is larger. On a larger level. It means that the brain part X assumes that they have to cover up or take the work of brain Y part. So this basically means maybe during the time of injury or something, or brain damage or something. So what cortical remapping really means is that when a person, for example, there is a person who meets with an accident, and when they met with an accident, they got a head injury and some part of their brain got hurt and damaged. So in that, what happens, let's say for example this person lost the vision. So now what is happening, the person has lost the vision, they cannot see. Earlier what was happening, you were seeing things with your eyes, you were listening, you were speaking, and you were smelling. So these are the sensations, and touching as well, of course. So these were the things that were happening. Now, have you heard that people who are blind, they have a very sharp hearing? Now, why does that happen? That is because of the neuroplasticity, cortical remapping. So what happens is, let's say there is a person who just met with an accident and lost his vision due to head injury. Now, when the person lost the vision, earlier, let's say he was using his, of course, eyes to see things, and then, ears to hear things. But when the vision was lost, now the sensation that eyes were capturing earlier, now that is not happening. And all the load of eyes are now have fallen onto the ears. So now ears have to take up that place and see that I need to sense things around me, sense the environment around me, and all the load is on me only. I mean my ears I'm talking about. So now because eyes are not there, I cannot see things, and number of things I won't get to know. So my touching, my smelling, and my hearing, all these sensations sharpen altogether because I'm using it more to sense my environment around. So earlier I was seeing with my eyes as well. So ears did not have much load, or smell or touching was not having much load. They all had, kind of load was all distributed among all these senses. But now when the eyes are not there, what has happened? The load has increased on the other senses. Now they are responsible for understanding that what is happening around the environment. So if you see a blind person, their smelling and their hearing is more sharp sometimes than the normal person, because they have to use their ears for understanding what is going on in their environment, or smell or touch to understand, because the eyes are not there. So that is why when they are using those parts of the brain more than before, the synaptic connections in those particular areas have now deepened. They have now become more strong than before, and now that is the reason their hearing and their touching and smelling has increased as compared to before. Somewhat cortical remapping. Another example would be like, for let's say somebody loses one of their arms, and let's say it is the right arm. Most of the people are right-handed, so I'm just giving an example here for the right hand. So there is this person who met with an accident, and due to some unfortunate circumstances, that person, what happens is, earlier the person was using doing lot many tasks only with the right hand. So the right hand was the dominant one, and he was using all these things with his right hand. So this was a stronger hand, even like physically, to pull up things, to push and pull and pick up things. For everything, the muscles of the right hand were much stronger for this right-handed person. So after the person loses his right hand, what happens? all the load has now come to the left hand. Now the brain knows that everything that is to be done has to be done by the left hand. There is no other way. The person doesn't have right hand now. So what happens? The person starts using his left hand for eating, pushing, pulling, picking things, and so on. So when the person is using his left arm, earlier which he was using right arm for pulling things, and now right arm is not working, now they have started using their left hand, left arm. The muscles of the left arm become much stronger. Why? Because they are being used more. So anything that is being used more becomes more stronger and better. Anything that is used less becomes less stronger. So here what has happened, this switch of the muscles and usage has happened. There's this beautiful saying in neuroplasticity, I really like this, it rhymes really well. Neurons that fire together wire together. There's this beautiful saying in neuroplasticity, I really like this, it rhymes really well. Neurons that so this simply means that neurons that keeps firing as in communication is happening continuously. So the usage, it's being used basically. So when it keeps firing, the neurons, those always wire together. So neurons that fire together wire together. Neurons that fire out of sync fail to link. So that means the neurons which are not able to sync, they are not able to link. So it is good. Please keep using your brain for all the productive activities that are there. So that means the neurons which are not able to. Another is axonal sprouting. Even that is very interesting. It means that every axon that starts does not mean it will reach up till the age of the full functioning of axon. Basically, sprouting is what? Sprouting is early growth of an axon that may or may not complete the journey of reaching the target neuron and restoring function. So it is the key structural change that makes the plasticity happen to facilitate development of normal neurons and recovery of functions of injured neurons. Sprouting declines with age. Axonal sprouting is a process where fine nerve processes, sprouts, grow out from the intact axons to re-innervate denervated muscle fibers. Thereby, the sprouting sustains the nerve supply to muscles and in turn the ability to move. So what is happening is that when the axonal sprouting happens, sprouting is what? Just starting of the axon. So when the starting of the axon starts to happen, it does not mean that it will be fully functioning. Only if we use it, it is going to grow and have further dendrites like branches kind of a thing. If we do not use that particular area of the brain, we do not use any ability in regarding to that neurons or axons, that axon does not completely grow and is shed off. So when a child is born, there are number of axonal sprouting that is happening. There's so many sprouts, all kind of axonal sprouting is happening. So as the baby grows, like initially in the starting of the lecture, I said that a baby's brain is developed till the age of 5. A child's brain is developed in the age of 5. It does not mean that your brain is not going to change throughout your life after you reach the age of 5. Nothing like that. It keeps changing. But the maximum kind of synaptic connection making and breaking happens during those early 5 years of your childhood. So that means when a child, comes in contact with number of things in their environment. So that is why when we say that, for a smaller child, make a good environment and, present them with good stimulus, positive stimulus. Why we say that? Because we want those particular positive, good synaptic connections to be made and the other ones to be shed. So that is why the reason that we say that, until the age of 5, don't let them watch TV, don't let them watch iPad or mobiles, because they kind of ruin your synaptic making. So better give them some books. Maybe they just turn the pages. They don't know how to read, of course, a 5-year-old. So they might just play with a book or they play with some educational toys from which they are learning. So that is very important. Why? Because these educational toys and books around and positive environment around is going to build up some new good neurons. So what happens, axonal sprouting here is that it only sprouts when it is being used. It reaches up till that age and it makes more connections. When it is not being used, that just gets shed off. So that is what axonal sprouting it is, the early growth of axon, which may or may not complete the journey of reaching the target neuron and restoring function. Then another important terminology is synaptic pruning. Synaptic pruning is the natural process that occurs in the brain between early childhood and adulthood. During synaptic pruning, the brain eliminates extra synapses. Excess of pruning can lead to the onset of schizophrenia. Too little pruning can lead to autism and epilepsy. Now, if you see in this picture, at the age of 36 weeks, that means when the fetus is there, we are talking about fetus here. It's in the mother's womb, only 36 weeks. This is the amount of neural connections that have been made. And the newborn has got these many, a little bit more. 3 months, the neural connections have been increased. And if you see by 6 months and 2 years, there are too many synapses that have been formed. By the age of 4 and 6, if you see, the synapses have decreased. Now what is happening? I'll again explain in a very layman language. Now when the child is born, there are in initial 2 to 3 years, the making of synapses are just too many. There is too many. It's like millions and trillions of synapses are being made. All kind of connections are being made. Now, having too many connections is also bad. It can lead to autism or epilepsy. Why? Because there is too much of traffic jam. There is too much of firing that is happening in the neurons, and which you don't really need. So it is really going to bother a child or a person when too much of firing is happening. So that we do not need. We need only those synapses that we are going to use. So initial 2 to 4 years, whatever the child does, the kind of environment they have, the kind of stimulus that they get in touch with, those particular synapses, brain thinks, now this child, there are too many synapses there, connections are there. Now the brain thinks that we don't need so many connections of synapses. Okay, let's break the ones which a person doesn't need, and we'll keep the ones that a child might need. So this is called pruning. Pruning means shedding off these neural connections that are there. So this shedding of the neural connections are very, very important. Why? Because we do not need so many connections in our brain, because excess or the lack of neural connection, both can be a problem. So basically what you have to remember is axonal sprouting was making of it, pruning is breaking of it. So pruning is a very, very important part. Now why? If there is of breakage is there, it can lead to schizophrenia. The person is not able to think right. There are hardly any neural connections in their brain. On the other hand, if the pruning is very less and there are too many connections there, that means a person can have autism or epilepsy because of excess of the neurons and synaptic connections, and there is less pruning that has happened. So in initial, when the child is very, very small, at that time, like 2 to 3 years, that time it is important that the right amount of pruning happens. So we don't want those synaptic connections that will not be using. Only those synaptic connections will be kept in our brain or be kept in our brain, which a child would be needing. So that is what pruning is. We'll be using some technical terminologies here to understand better, and so that you can write in your answers as well. There are two aspects of neuroplasticity. One is dendritic branching and another is pruning. Dendritic branching, like I already told you, the branches are made. Okay, so more synaptic connections are being made. Dendritic branches are like the branches, like just the branches of trees. So these are being, made more and more, and the connections are happening. Pruning is the shedding of the same. Now, one form of neuroplasticity is the strengthening of synapses. Now, when we say neuroplasticity, basically neuroplasticity is both the changing of the brain. It can either be making of the synaptic connections or breaking of the same. So, neuroplasticity is the strengthening of synapses. This is due to the process called long-term potentiation, LTP. It argues that the repetition of a task results in neuroplasticity. LTP also leads to dendritic branching or dendritic arborization, which leads to an increase in neural density. So, more you are using your brain for a particular thing, more dendritic branching is happening. That means you are getting better in doing that ability. The neural density is increasing, you are doing better in that particular ability or skill. So, lack of potentiation as a result of discontinuation behavior may lead to neural pruning, the process by which extra neurons and synaptic connections are eliminated. So, for whatever thing you are not using your brain, those connections are going to break or going to shed. So that is the pruning. Now, I made you understand in the layman language, but here I am using some technical terms because I want you to write these in your answers to get better marks. So make sure that you use this kind of terminologies in your answers. So here we are done with the neuroplasticity. Extremely beautiful chapter, extremely beautiful concept it is. It clearly gives us hope and encouragement that it's never too late to learn something new. Of course, a child can learn faster than you because the being made very fast in the in a smaller child as compared to the older person. But still, that does not mean that it's too late for you and you'll not be able to learn. You definitely can learn new things in life and keep using your brain as much as possible to build up those synaptic connections strong enough